Hello, grade 11s. We're on our third day of sequences and series. Yesterday we looked at arithmetic sequences, which is where a sequence goes up by a common difference. So you're adding the same thing to a term to get the subsequent term. And we also looked that sequences are patterns of numbers that go up in a predictable way. So let's make sure that these sequences are in fact sequences and determine whether they're arithmetic or something different. The first one, 4, 8, 16, does proceed in a predictable way. You know to get a subsequent term, you're going to double the number before it. So I know that I could generate future terms by doubling and so on. This is not an arithmetic, however, because I am not adding to a previous term. So it's not arithmetic, but it is a sequence. The next one, -9, -7, -5. This one does proceed in a predictable way. -3, -1, I could predict future terms. And it does, yes, to sequence, and it does go with a common difference. So it is arithmetic as well. My common difference would be -2. I can't spell. There we are. The third one, 4, 16, 64, is a sequence. You could find subsequent terms by multiplying by 4. So it is predictable, following a pattern. It is a sequence, but it is not arithmetic. Third one, 3, decimal 0.03. Predictable, decimal 0.003, decimal 0.0003. It is a sequence. It is not arithmetic because you're not adding to find future terms. We are multiplying by 1/10 to find future terms. Not arithmetic. 1, -4, 7. 1, -4, 7. We can find future terms. The value, or the absolute value, of each term is going up by 3. So my next term would be -10, because it seems to be alternating between positive and negative. 13, -16, and so on. But it is not arithmetic. You are not adding the same thing each time to get a subsequent term, nor are you multiplying each time. Could we come up with a recursive formula for this one? I'll leave that with you. Geometric sequences. We've looked at a couple. This one, and this one. Where they are not arithmetic, you are going up by multiplying. The number obtained by dividing any term by the preceding term as a constant gives us a geometric sequence. So to obtain a future term, you multiply by a common ratio. In arithmetic, we added a common difference. For geometric, we are going to multiply by a common ratio. To find that ratio, we would divide any term by the preceding term, or by the term before. So for the first one, I mean, mostly you can eyeball them, but you can see that 8 divided by 4 is 2. So our ratio is 2. Check. Is 16 divided by 8 2? Yes. For the second one that I've starred, 16 divided by 4 is 4. Our common ratio appears to be 4. Check. 64 divided by 16 is also 4. And so on. Common ratio. First example, Kenny heard of a foolproof way to make a fortune. Save a penny the first day, and then each day double the amount saved on the previous day for 30 days. So on day 1, 1 cent was saved. On day 2, 2 cents were saved. Day 3, 4 cents, and so on. How much would he save on the 10th day? We can write it out. It's easier to see if we do it as a sequence. 1, 2, 4, 8, 16, 32, 64. 1, 2, 3, 4, 5, 6, 7. We've got a few more to go. 8, 9, 10. So on the 10th day, whoops, that's not dollars. 512 cents. On the 30th day, well, I'm not so very sure that I want to write this out so very many times. Our 30th term will be 2 times the 1 cent, and I double it, and I double it, and I double it, and I double it again. 29 times, actually, because on the first term, I haven't doubled anything yet, and my answer is going to be ridiculous. Just a second. Right, 5,368,709 cents on the 30th day. I started with 1 cent, and then I doubled it 29 times thereafter. So just to reinforce how we get our common ratio, we are taking subsequent terms. So I can look at 4 and 1. Common ratio is 4, or I could look at 64 and 16. It doesn't matter. If it is a geometric sequence, then any 2 subsequent terms will give you the ratio. 15 divided by 5 is 3, or 135 divided by 45, any one of them would give you the ratio. 6 divided by negative 3. My common ratio is negative 2. 24 over negative 12. Negative 2. Determine the value of the 7th term in the geometric sequence 2, 6, 18, 54, 162. I can write these out. I've got 5 of them. So the next term, I am tripling. All right, I found my ratio. I've started with the number 2, and I am tripling each time. So my next terms will be 162 times 3 is 486. And then times 3 again, 1,458. Term 1, 2, 3, 4, 5, 6, 7. Term 7 is 1,458. Here's our summary. Sequence that has a common ratio. Between terms is a geometric sequence. In general, a geometric sequence looks like initial term times the common ratio, initial term times the common ratio twice, initial term 3 times, and so on. The general term is Tn equals initial value times the common ratio to the power of n minus 1. These should look familiar, where A is the first term, R is the common ratio, N is the term number or position, so the third term, Tn is the value of the nth term. We call this the general term. Given the formula for the nth term of a geometric sequence, Tn equals 5 minus 2 to the n minus 1, write the first 5 terms. So our initial A is 5. Our ratio is -2. Just looking at the form we had on the previous page. Is that true? If I have T1, will I get 5 as I'm expecting to? Let's put a 1 right where the n is. I would have 5 times -2 to the 1 take away 1 is 0. What is -2 to the 0? Anything to the 0 is 1. So I will end up with 5 times 1 is 5. Yes, my first term is 5 as I expected it to be. My second term is 5 times -2 to the 2 take away 1 is 1. It's -10. My third term is 5. -2 to the 3 take away 1 is 2. 5 times 4 is 20. T4. 5 times -2 to the 4 take away 1 is 3. -2 cubed is -8, -40. And my last term is 5, -2 to the power of 4. 16 times 5 is 80. Let's write it out like a sequence. 5, comma, -10, comma, 20, comma, -40, comma, 80, and so on, which is easier to see. Determine the general term and the 12th term for the following sequence, -3, 12, -48, 192. This is a geometric sequence. I can tell because I'm not adding a constant number. I am multiplying by 4, -4, each time. So my ratio is -4. I've done a quick mental check that all 4 terms it is the same. My initial or first term is -3. So the general term is -3, my first term's value, times the ratio to the n minus 1. Let's find our 12th term. T12 is -3 times -4 to the 11. Yikes. So I have -3. -4 to the 11 is negative. And I did this in my head. It's 4194304, of course. And a negative times a negative is a positive. 1, 2, 5, 8. 2, 9, 1, 2. In the old days, we used to put commas. 12,582,912 is our 12th term.